Now, sometimes when you get a logarithmic function, you're going to want to rewrite it first before you take the derivative of it. Now, that doesn't mean if you take the derivative straightforward without rewriting it, that doesn't mean you won't get the right answer, because you will. It just makes it a little bit more complicated. So what's always our strategy here is to try to find the easiest way to get an answer. So what you see originally when you have a question like this is you have a log, or ln, to some expression raised to an exponent. And so then you have to think of your laws of logarithms from pre-calculus that were initially posted in one of the videos. Remember, pre-calc rule. When you have y is equal to ln of a to the b, that can be rewritten as b times ln a. B times ln a, which is not a derivative. Remember, this is a logarithm law. So I could rewrite this, and it's not using a power rule. We're not doing any calculus here. We're just rewriting it. So y, not y prime, but y, is 3 ln 2x plus 5. Did I put a 2 there? No. I did pre-cal here. Pre-calc, 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 pre-calc. Then from here, this is a really easy question to differentiate. All you have to do is use your ln u law. So the derivative, now notice how my notation changes. Y prime, 3, 1 all over 2x plus 5 times the derivative of the inside, which is 2. This is very similar to a question that we had right in the beginning, where it's 3 ln x or 5 ln x. Remember, the constant comes and continues as a constant function in front of the derivative. So the final answer for the derivative is 6 all over 2x plus 5. Again, so many times I see students tell me, oh, I did the power rule here, 3 ln 2x plus 5 squared. And I'm like, oh my goodness, no, you can't do that. Make sure that you realize that this is a pre-calc law. It's a law of logarithms, not a differentiation law. So you use that law where you have, when you raise a power to a logarithm, that number can jump in front. Still pre-calc. It's still y. It's still y. Okay, and then that would be an easier way to get your answer. But you can also go about answering this using ln u and then taking the derivative of that term. It just becomes a little bit more time. This is much quicker along the way. And the more examples you do of these, the better you'll get at it.